Hello, everyone. My name is Tim Tang from Hughes, and today I have the privilege of speaking with Pradhyum Ramkumar from Celona. Pradhyum, can you talk to us a little bit about what are some of the key pain points in the manufacturing industry?
Hi, Tim. I'm very happy to be here. Thank you for the opportunity. So manufacturing is one of the areas where we're seeing a lot of traction in private 5G. And in manufacturing, I think the big pain points that are driving this stuff is, the increased cost of manufacturing productivity, as well as the shortage in labor. Most of the places are having increasing labor costs that's affecting the cost of the products they make. So along those lines, in a factory, the number one use case that we are seeing is predictive maintenance. So what is predictive maintenance? It is a machine when it is self-detecting that it's going to fail before it actually fails, so that people can fix it and get it going before it actually fails. So this is the underlying concept of whatever it is, Industry 4.0, predictive maintenance, digital twin. There are multiple ways and multiple technologies riding on it, but underlying is predictive maintenance. How do you predict it before it fails? The second big trend that we're seeing in manufacturing is that all manufacturers want to have an agile assembly line. So when you think about a factory, you think about items going from point A to point B in a linear assembly line as they get built up. But the modern way of thinking is, well, I may want to do object A on day number one and object B on day number two. So how do I set up my assembly line so that I can have a very agile process of manufacturing anything I want? Well, in order to do that, you need what is called retooling. You need to be able to move your tools across the manufacturing floor so that you can set up different stations where what you're trying to manufacture is actually going across the factory floor. But in order to do that, again, you need the ability to connect those different pieces of machinery as they get retooled into a different location at the factory. The third use case in manufacturing, again, goes back to the labor shortage we spoke about, is the use of AGVs. AGVs are autonomous guided vehicles. There are different flavors of it, whether it is fully automated or semi-automated. But these are front and center in most of these manufacturing shops, whether it means you're bringing the raw materials from a yard to inside a factory station, or moving finished goods from the factory back to the warehouse. All these are getting automated with AGVs, and AGVs require connectivity no matter where you go. And then finally, back to worker productivity, you have connected labor, connected workforce that might have a Zebra tablet or something to scan objects, maintain inventory of what's going on, what's raw materials coming in and the finished goods going out, and all of them require connectivity.
Can you talk a little bit about today's solutions in manufacturing? What are some of the weak points?
Most manufacturers have traditionally preferred wired connectivity, and for a good reason. The autonomous robots, when we speak about them, again, you cannot have a wired connectivity for them, so you need wireless connectivity. And the challenge with deploying them on a Wi-Fi network is that Wi-Fi, again, does not support roaming, right? As the AGVs are roaming from maybe an outdoor yard to inside the factory, it's not going to be very reliable connected over a Wi-Fi network. And secondly, to go and add Wi-Fi across such a large area is also problematic. Just one metric from a manufacturer, we were able to convert a 320,000 square feet manufacturing floor with just 8 private 5G access points which require an equivalent of 59 access points previously. So those are the numbers that you see when you look at Wi-Fi based connectivity. Wi-Fi is not reliable because of you need a lot. Wi-Fi, you're going to need a large number of access points. You're going to have high latency or unpredictable latency, and it does not support mobility. Those are the reasons Wi-Fi doesn't fit. And then finally, we talk about public cell phone coverage. And when you talk about public cell phone coverage, again, you are looking at very dense metallic structures inside a building. So just because you have good coverage outside a building, outside a manufacturing floor, does not mean that the public cellular is going to work well inside the building. And for that reason, both wired and wireless connectivity standards have issues.
Wow, you've outlined quite a bit for us to kind of consume, thinking through the seamless roaming requirements, thinking through the ubiquitous kind of ultra-large area coverage requirements, and then even just the mobility requirements from a mobile device perspective too as well. Can you talk a little bit about what are some of the advantages then of a private 5G implementation?
Sure. So again, some of the same things I mentioned about in the past. So let's first talk about coverage, right? So now you need reliable coverage, not just in the indoors, but also in the outdoors, because most of these operations are indoor-outdoor type operations. And in that light, I'm going to share some statistics with you, which might come of use. So for example, we looked at one factory which had both an indoor setting and an outdoor setting. The indoor setting was about 320,000 square feet. So 320,000 square feet required an equivalent of 60 Wi-Fi access points. And when you went with the private cellular, you needed only 8. And then in the outdoor yard, so the manufacturing floor had a 1.3 million square feet yard, which would have required 52 Wi-Fi access points, and we were able to do it with just 4. So as you can see, it's a significant drop in the number of access points for the same level of coverage, or even better. And the reason for that is private cellular is a cellular technology. It has a higher transmit power and works very well to cover large areas. So coverage-wise, you cannot beat the power of private cellular over Wi-Fi. The second reason why somebody might want to consider private cellular over, say, a Wi-Fi network is the latency aspect of it. So now, as we had spoken, many of the things that happen in a manufacturing floor are very low latency applications. You push the button, it needs to stop. It cannot take, 1 second to stop. So that is called latency. So in a manufacturing environment, the latency for most operations need to be less than 100 milliseconds. And with private cellular, because of the QoS aspects built into private cellular, we are able to guarantee that the latency of the operation can be bounded and it can be within 100 milliseconds. On the contrary, with Wi-Fi, latency can be low, but it can also be very high, and you have no way to control the latency aspect of it, and which is why it is not preferred for factory automation type applications. The third important thing is handover. As we spoke about AGVs and mobile equipment that relies on wireless connectivity to operate inside a factory, both indoors and outdoors, one access point is not going to be able to cover the whole factory floor. You're going to need multiple access points. And as the equipment, as an AGV, for example, traverses multiple access points, you want to have seamless handovers between point A and point B. And you cannot guarantee that with Wi-Fi. So you might get into a situation where your AGV travels halfway and stops because it's waiting for connection. Whereas we can guarantee operations like that with private cellular because it is developed for mobility. cellular has stress-strained mobility on the public networks, and we're bringing the same technology into the enterprise environment.
Actually, Pradhyum, could you maybe explain a little bit more about how are you able to guarantee quality of service, latency parameters? Can you speak a little bit about microslicing?
Sure. So you should understand the fundamental behavior of Wi-Fi and private cellular in order to answer that question. In Wi-Fi, for example, it is a contention-based protocol. A device comes into a Wi-Fi environment. So it is basically going and asking the router, hey, give me an IP address, connect me to the network. And then you can have multiple devices, and all of them are contending and trying to connect to that network. So sometimes the device that you're trying to connect just connects. Sometimes it does not. And same thing happens to the traffic segmentation network priority. So, when data packets are getting sent over the Wi-Fi network, all of them get treated the same. When somebody is like maybe browsing a YouTube channel versus some mission critical data getting on the network, they all look the same to the Wi-Fi access point. What is different with private cellular is the fact that the network infrastructure, the access point, determine the priority of which devices connect to it and which specific packet on that network needs to be prioritized. Celona has developed a technology called microslicing that sits on top of the cellular 3GPP standards and is able to prioritize a device or a particular type of application. For example, a customer might want to prioritize a PLC application on the private wireless network over maybe a worker communication application. So we can actually prioritize either the application or the device on the Celona network very easily with high level of reliability, getting you to less than 30 millisecond latency on the network.
You've spoken about quite a bit about the benefits of a private 5G networks. Can you talk a little bit about what's involved in implementing and operating a private 5G network?
So private 5G networks are, generally people get scared. Do I need to have a whole army of cellular engineers on my team if I want to support a private network? And the answer is no, because you have to look at the network in two phases. One is somebody to set up the network, and then we call that, day zero, day one type of setup. And then you have day one to day N, where you're managing your own network. From day zero, day -1, day zero, RF planning, looking at your plant and finding out where to set up access points so that you have the most robust coverage in your facility. Yes, it requires cellular expertise, and that is where companies like Celona, like Hughes, comes into play, where we bring that expertise to set up the network and get it going. And then when we hand over the keys to the kingdom, you look at the network and you are going to manage it very similar to the way you manage a Wi-Fi network today. Bringing in new devices online. What is the security policy associated with it? What is the QoS policy associated with it? You have tools, integrated tools, to go set up all these things. There are some nuances associated with SIM management and SIM provisioning and things like that, which are, again, it's not the most complex thing in the world. And tools like the One Celona Orchestrator enable you to manage those tasks very easily on a single pane of glass today. So managing a network isn't that complicated. Setting up the network, we'll take care of it for you.
Excellent. And maybe one last question. Can you speak to the state of private 5G today? Specifically, what kinds of industries are already using 5G?
I think we are very, very early in. And the way we look at it is greenfield versus brownfields. So what is greenfield? Greenfield is, well, I don't have any cellular technology today. What is the right, or I do not have any wireless technology today. I'm setting up a brand new chip factory, or I'm setting up brand new automotive factory. How do I go about it? there it's a no-brainer, right? Because you don't have any legacy stuff. You want the best coverage to cover every part of your factory. Then, go directly for a private wireless network. And which is where we are finding most of the new factories, emerging factories, either with the CHIPS Act that we're talking about, chip factories and new automotive factories, all of them are aligning around that mindset. If you have a brownfield opportunity wherein you may already have wired connectivity, you may already have Wi-Fi. Well, if it works for you, then that's great. But what we're seeing is with the advent of all these other new things that we spoke about earlier in the program, HEVs and connected workforce and things like that, they are seeing some shortcomings, and which is where existing manufacturing, traditional manufacturing, as we call it, the guys that build electrical switch boxes, the guys that build tractors, the guys that build very, very traditional stuff that everybody uses, they are looking at retrofitting their existing factories with private 5G. And since it sits as an overlay network, it's not going to interfere with your Wi-Fi. It's not going to interfere with your existing wired network. It's quite easy to add.
That's excellent. Thank you, Pradhyum, for speaking with us today. Everyone, I've been speaking with Pradhyum Ramkumar from Celona, and we've been talking about the private 5G use cases for the manufacturing industry. Thank you very much for listening.